Welcome back, and we saw trigonometric points for the compass points. We want to develop some more trigonometric points in this video. All right, so we're going to start by looking at the line y equals x and its relationship with the unit circle. So I'm just going to first draw kind of a sketch of the unit circle in black here, and this is going to be free-handed, so it's not going to be perfect, but we'll get the idea. Okay, so there's our unit circle in the first quadrant. Okay, so this is y, this is x, and then this is going to be the equation x squared plus y squared is equal to 1. Okay, and now I'm going to look at the line y equals x. So that's going to split if y is equal to x, that you know from previous studies is a slope of line 1, and it's actually going to bisect our first quadrant. So this is a line y equals x. Okay, so first, okay, this is fine, but when we talk about trigonometric points, right, we want to find p of t is equal to x, y. So we have a few different tasks to do. We need to find x and y, and namely that point is going to be right there, right at the intersection of the line y equals x. And then at that point, we want to find what t is, how far along the unit circle, we've gone to get to that point, what's the arc length, right? So we need to find these three things, okay? And I think t might actually be the easiest question mark thing to find first. And what we have to do to find t is remember that, okay, in radians, right, this would be 0 radians. I'm going to omit 2 pi because we haven't gone a full circle. And then up at the positive y-axis, this would be pi over 2 radians, okay? So if we go, from the x-axis up to the y-axis, positive axes that is, that's pi over 2. So if we think about this line, right, the question is how far will we have gone in terms of radians to get to this line? Well, it would be, and this line, remember, it bisects, that means splits in half, okay, it bisects, so this would be pi over 2 divided by 2, okay, and then we have to do a little bit of algebra perhaps, but it comes out to pi over 4, okay? So this is our angle theta, right, and then remember, on the unit circle, t is equal to theta, so t is equal to pi over 4. So for this point, we have a start to it. We have p of pi over 4 is equal to x and y, and remember, these are going to be the same value. Okay, so now our job is to find x and y. Okay, and we do that by our handy-dandy equation of the unit circle. X squared plus y squared is equal to 1. Okay, and remember that y is equal to x, so then we just substitute in x for y, so x squared plus, and then we have x squared is equal to 1. Okay, x squared plus x squared is equal to 1. Algebra is our friend. 2x squared is equal to 1. Coming over here now, I'm going to do x squared is equal to 1/2, and then x, if I introduce a square root, x is equal to square root of 1/2, and then a little voice inside my brain is telling me when I introduce a square root, I need the plus and minus. Yep. Okay. So this is fine for me, and uh, our online systems and whatnot will generally balk at us and say, this is not right. This is not simplified. So if you want, you can say that this is plus or minus the square root of 1 over square root of 2. So plus and minus 1 over square root 2. And then rationalize this thing. So if you want a whole number in the denominator, multiply by the square root that is in the denominator to both numerator and denominator, and you would get plus or minus, let me make that a little bit clearer, plus or minus square root of 2 over, and this would be square root of 2 times square root of 2, square root of 4, also known as 2. Okay, so we're going to go with that. So in all, we have the trigonometric point P of, and I should actually probably write this down where I have it. So we have the point P of pi over 4, that would be the arc length, is equal to xy, right? But x and y are equal, okay? And, oh shoot, I have plus and minus. Which one do I use? Well, now I want to think about the first quadrant. First quadrant, x and y are both positive. So x is greater than 0 and x is greater than 0 and y is greater than 0. So I'm just going to pick the positive form of this. Okay, so square root of 2 over 2, comma, square root of 2 over 2. Okay, we'll see the negative come up soon enough. Okay, so we have that trigonometric point. Okay, so in addition to the compass points, we have another one in quadrant 1. All right, next one, the next trigonometric point that we're going to find is related to a 30, 60, 90 triangle. Okay, and so what I want to imagine, just bear with me, okay? I want to imagine that this is a length 1, which then, so this side length is length 1, this side length is length 1, and this side is length 1 since it's an equilateral triangle, okay? And now I'm going to imagine, and then I guess also since it's equilateral, this is 60 degrees, this is 60 degrees, and this is 60 degrees, okay? Equilateral or triangles are also equal angular. All the angles are equal, okay? Now I want to imagine making an angle bisector. Okay, so angle bisector is going to take and split that 60-degree angle into two new angles that are half as much, so 30 and 30, okay? And then you can see we get smaller triangles out of this, and in fact, when the angle bisector hits the opposite side, it is a right angle. It creates a right angle, okay? Now, this is maybe a lot of geometry too, but when you have an angle bisector in an equilateral triangle, that's actually a perpendicular bisector of that side. So we see the perpendicular piece here, but bisector of a side means that that side length gets split. So from there to there is 1/2, and 1/2 is also from there to there. Okay, that's the side length for that. Okay, so now we know the side lengths here, and then we can find, just for fun, find the side length here, this shared side length x. I'm going to do this off to the side, so x squared via the Pythagorean theorem. So side or leg squared plus leg squared is equal to hypotenuse squared. Okay, x squared plus 1/4 is equal to 1. X is equal to 3/4, x squared, and then square root both sides. X is equal to plus or minus square root of 3/4, which we can keep reducing, plus or minus square root of 3 over square root of 4, plus or minus square root of 3/2. Okay, and we're talking a triangle, so we're just going to go with the positive version of that. Okay, we can't have a negative side length in a physical object. Square root of 3/2. Okay, so this is fine. Now, the whole reason we did this is I want to imagine this circle overlaid on the Cartesian coordinate system. So I'm going to put this point here right at the origin. Okay, and since this is a side length of 1, we can imagine that this is, it's not going to work super well here. But we can imagine that that is a radius of our unit circle. Okay, and so what we can say is this point right here is a trigonometric point, right? P of t is equal to xy, okay? And P of, well, t is an arc length, and remember on the unit circle, arc length is given by the measure of the central angle in radians. So the question is, what is 30 degrees in radians? You might need to look this up or do the math. Pi/6. Okay, so we have the trigonometric point that is P of pi/6 is equal to xy. So the question is, what is x, what is y? Well, let's use our diagram. How far did we go in the x direction? That was the square root of 3/2. How far did we go in the y direction? 1/2. Awesome. Okay, we found another trigonometric point. Yay us. Okay, now I'm going to give you the other trigonometric point that we're supposed to find. P of pi over 3, which is 60 degrees, is equal to 1/2 comma square root of 3 over 2. Okay, how do we get this? We would just need to rotate our diagram a little bit. And you could imagine, I'll just draw a quick little sketch. Little, and I mean little, okay? So if you had 60 degrees here, 60 degrees, this is still 90, right? Then this would be 30. Apparently my dog likes what we're doing. And so then this is 1, this would be the 1/2, and this would be the square root of 3 over 2. So then x is 1/2 and y is square root of 3 over 2. So we have 2 more trigonometric points. And so that is our punchline here. I did all the work above here, so we'll just leave that blank. So the points p of pi over 6 is equal to square root of 3 over 2, comma 1/2, and p of pi over 3 is equal to 1/2, comma square root of 3 over 2 are trigonometric points. Okay, so now we have a few more trigonometric points to work with that were found using some fun geometry.